Okay, so reasons for doing this partial fraction stuff is so that you can do differentiation and calculation and integration in an easier way. So if we want to differentiate the function we've got here, the 11x squared, what I can do is I'm going to differentiate each of the terms separately. So first one, let's do d dx for minus 2 over x plus 1 all squared. Along the way, you're going to use the chain rule, so we can do a chain rule on u. Let's just do on the x plus 1. So du dx is just 1. So this becomes the differential with respect to u of minus 2u to the minus 2 times du dx, which is just 1 in this case because of the differential of that. So differentiating this, we get 4 over u cubed, which is 4 over x plus 1 all cubed. So let's do the next part, the differential on the third one. So this is the second video. So let's do the next term, which is the 4x plus 1. And this is where we're going to start getting 4x plus 1. Again, we're going to use u as x plus 1. So this becomes the differential of 4u to the minus 1 with respect to u. Du dx, again, is 1. So we get 4 u differentiates to give me u to the minus 2, so over u squared times the 1. So that becomes minus 4 over x plus 1 squared. And I'll put the other one up here so we can still see the expression on the screen. We also want to differentiate 3 over 2x plus 1 with respect to x. And again, we're doing u, the denominator x plus 1, du dx. This time it's going to be 2. So the chain becomes d d3 over u, no, 3u to minus 1, probably nicer to write it that way, dx, du, times du dx, and this becomes negative 3 over u squared with times 2, which gives me minus 6 over 2x plus 1 all squared. So the result of this differentiation I can write out as being d dx with that expression is equal to the 4 over x plus 1 cubed minus 4 x plus 1 squared minus 6 over 2x plus 1 all squared. So that's one use for it. I'll create some more space and we'll do the integration as well. So I need all of this stuff going forward. Okay, so we're going to integrate each of these separately, do it in a sensible manner, going through piece by piece. We can do it by substitution, by saying x plus 1 is the u, change the subject of the formula. And so let's go through and do the first step. So I'm going to say I want u is x plus 1. I've got du dx. It's going to give me 1, which means du can directly replace dx. So I can substitute that straight into here, and we're now trying to look at the integral of -2 over u squared with respect to x. And when you integrate, we need to u squared, I've got that, integrate that. So when we integrate this, that's through there, integrate. So when we integrate, we raise the power. So this is from -2, it becomes a -1. We've got -2 u to the -1 over -1 plus some constant, which is going to be 2 over x plus 1 plus some constant, but the constants from each term will collect together to create another term. So the next one, do the same thing for this one. We're going to integrate, and this time when we do 4 over x, we can actually use the pattern, because this is f dash over f. So the integral of f dash over f is equal to log of f plus some constant again. You sometimes have to play about with the constants. With this one, because of the differential of this being 1, the 4 is going to wind up staying. So this one, the integral becomes 4 log x plus 1. And same idea here, but this time it's going to be 4, but the differential here is 2. So that's going to be 3 over 2. So hopefully you'd recognise this one again as being the same thing. You've got the integral of f dash over f dx, and that's going to be some constant of ln of f. And the thing we're going to divide by is the differential of the term here, which means we're going to divide by the 2. So this k value is k over f dash the constant. So we're correct for the constant. Let's show it. So u equals 2x plus 1, du dx is 2. So to be able to do the integral of 3 over 2x plus 1 in terms of u, so dx, doing it in terms of u is the integral of 3 over u. To change dx, we can do du d over 2. So that's where my halving I was talking about comes from. And this turns into a log of u. So it's 3 log of u over 2 plus some constant, or 3 halves log 2x plus 1. Closed it off, plus some constant. So all of these terms come together and we get the final expression. The constant from the first one, the 2x plus 1, plus the 4 log x, 4 log modulus of x plus 1. Show that they connect together to give that one. It's not part of this equation on the right hand side. Plus 3 over 2 log 2x plus 1. And all the constants come together. There should be a constant there and a constant there to give us a constant of integration.